Back with a Friday early evening edition of calculus. We're looking at day 42 here. This is a really important video, and this may or may not come naturally to you. It might take a lot of practice to get this down, but if we know our definitions well, that will help a lot. Okay, we're going to be interpreting the graph, a graph of f prime. Okay, a couple of things to know just as a reminder. These are things that are already in your notes, but I'm going to state them again. F is increasing when f prime is greater than 0. Okay, that means f is decreasing when f prime is less than 0. Okay? Critical point is when f prime equals 0 or undefined. Local max, f prime switches plus to minus. Local min, f prime switches, just do this, minus 2 plus. Neither f prime doesn't switch. Concave up, f double prime is greater than 0. Or I told you that there was another definition that's going to be important to remember. That also means f prime is increasing. This is going to be helpful today. Concave down. F double prime is negative, or f prime is decreasing. Inflection point. This is when f double prime switches signs. Or when f prime switches from increasing to decreasing. So increasing to decreasing, or vice versa. Okay. So knowing those definitions is going to be very helpful here. And because we're used to knowing, oh, what does a local max look like on f? Well, it's the highest point in its area. But now we're going to be looking at a graph of f prime. Right? So local maxes and local mins won't look like local maxes and local mins normally do on an f graph. Okay? We'll use our definition for this to help us. Okay, so what I want you to do is go ahead and pause the video and copy this graph down into your notes the best you can. Doesn't have to be perfect, but pause the video now, copy this down. Make sure you label the graph of f prime of x on the interval, closed interval from -7 to 7. Okay, we're back. So many times on the test, you will have to interpret a graph of f prime. Either a graph that's given to you or a graph that you will generate yourself on your own calculator. So here's what we have. This is not a graph of f. This is a graph of f prime. A strategy that I talk about with students is it'll often say that in the prompt, or it needs to say that in the prompt. I always write a big old f prime right here, so I never forget that what graph I'm looking at. Okay, I'm looking at a graph of f prime. Okay, the first question says, on what intervals is f decreasing justified? Okay. Now, in our head, when we think about decreasing, we think about, oh, the graph is going down. Okay? But notice it said on what intervals is f decreasing. So we don't want to look at the graph yet I don't care where this particular graph is decreasing because the question is about f and the graph is about f prime. So what I need to do is think back to my definitions, right, that I had you write down before. Go ahead and look up at your notes and see what happens when f is decreasing. Well, when f is decreasing, f prime is negative. So what I need to do now is report the interval where f prime is negative, not the interval where this particular graph is decreasing. So when I look at this, a couple of things. My axes aren't numbered out, so I might go ahead and do that, just so I don't make a mistake with numbering. And I'll do that over here too. So where is f decreasing? Well, f decreases whenever f prime is negative. So I only want to look at this graph. I want to report the regions where this graph is negative or where this graph is below the x-axis. Well, it's below the x-axis in this part over here and in this part over here. So those are the answers that I report. I don't care if this graph is going up or down. I don't care if this graph is increasing or decreasing. I care if this graph is positive or negative. So here's what we say. At what intervals is f decreasing? I'm going to say from -7 to -3. Union 6 to 7. I'll write f is decreasing. On that interval. My justification is because that's where f prime is less than 0. Okay? My definition has not changed. Okay? The only thing that's changed here is I'm looking at a different type of graph. I'm looking at an f prime graph. Okay? So let's look at question 2. Question 2 says, what are the x values of critical points of f? And then I want to explain if they are local min, local max, or neither. Okay? So I need to think back to the definition of critical point. I'm going to switch colors here just so this stands out a little bit. Critical points of f, I know by definition is when f prime equals 0 or undefined. Okay? So I'm looking at my graph. I want to know when is f prime equal to 0 or undefined. Well, when I take a look at this graph, I'm looking for the zeros. I see 1, 2, 3 zeros. I don't see any places where this thing is undefined. So my critical points are at x equals -3, 2, and 6. Now you may say, whoa, wait. I thought critical points are when the slope of the tangent line is 0. The slope at x equals -3 is not 0. Correct. But the slope of that line would be f double prime because we're looking at an f prime graph. Where is f prime 0? I just look for the zeros of f prime, this graph. The zeros are at -3, 2, and 6. I'm going to write those out down here. X equals -3, x equals 2, and x equals 6. Now I need to determine if they are local min, local max, or neither. Well, let's start with x equals -3. I know from my definition, right, look back at it. A local min is when f prime switches from minus to negative to positive, minus to plus. F prime on this side, right, over here, on the left side of -3, our f prime is a negative number. Our function is decreasing, approaching -3 from the left side. But then, on the right side of -3, our f prime is now positive. So f prime went from negative to positive. Therefore, we have a local min at x equals -3. And again, my justification is because f prime switches minus to plus. Okay? How about x equals 2? At x equals 2 here, I see a 0 there. But on the left side and on the right side of 2, f prime is positive in both of those places. Therefore, f prime didn't switch signs. F prime went from positive to positive. So x equals 2 is neither. And my justification is because f prime didn't switch signs. How about x equals 6? Well, at x equals 6, on the left side of 6, f prime was plus. On the right side of 6, f prime was minus. Therefore, when f prime switches plus to minus, we have a local maximum. Again, because f prime switches plus to minus. So that's how we determine critical points, local min, local max, by looking at an f prime graph. There's a 100% chance that you're going to have to do this on the test, most likely on multiple choice and on free response. It's not a guarantee it's going to be on one or the other, but it will be in there for sure. It's got to be. Okay? It's very heavily tested, very important concept. The next question is, on what intervals is f concave up? Well, look back to our definitions. F is concave up when the second derivative is positive. The problem is I don't have a graph of the second derivative. I have a graph of the first derivative. So I want to know about concavity based on the first derivative. Well, f is concave up when f prime is increasing. So what I want to do here is I want to look back to my f prime graph and determine on what intervals is f prime increasing. Well, I see f prime increasing right from here to here, and then I see f prime increasing from here to here. So I'm going to report those two intervals, -5 to -1, union 2 to 4. F is concave up on -5 to -1, union 2 to 4. Yeah, my justification is because that's where f prime is increasing. Okay, so -5 to -1, union 2 to 4. And that's where f prime is increasing. If I asked about concave down, I would have reported from -7 to -5, union -1 to 2, union 4 to 7, because that's where f prime is decreasing. The last one says, what are the x values of the inflection points of f? Justify. So looking back in our notes, inflection points are when we switch concavity. It's when f double prime switches signs, but we don't have f double prime or f. We have f prime. It's when f prime switches from increasing to decreasing, or vice versa, decreasing to increasing. So I'm going to use a different color here. Taking a look at this. Again, I'm looking for f prime to be switching from decreasing to increasing or increasing to decreasing. So taking a look, starting at -7, f prime starts off decreasing until we hit -5, then f prime starts increasing. So this point right here is an inflection point. F prime continues to increase until I hit the value of x equals -1. Then f prime switches from increasing to decreasing. Here's another critical point, inflection point. The next two inflection points are at 2 and at 4. Really, what it boils down to is these end up being what would look like critical points on f prime, or local maxes and mins of f prime, end up being inflection points of f. So our inflection points are x equals -5, -1, 2, and 4. Are inflection points. Okay. Those are inflection points of f, and I want to justify. I'm going to say, because this is when f prime switches from increasing to decreasing, or vice versa. Okay. So that's it for today. This is going to take a little while. We're going to do lots and lots of practices with this. And the more we do this, the more comfortable we'll get with it. The most common thing we have to do is interpret a graph of f prime. But we also have to interpret graphs of f, and we have to interpret graphs of f double prime. But this one is the bread and butter. This is the one that's tested the most. So that's all for tonight. Have a great weekend. Have fun. 2 chains. Bye.